Hello, good morning. Today I'm going to talk about bonding. Bonding in chemistry is divided into ionic bonding, covalent bonding, and number three is actually metallic bonding. So let me begin with ionic bonding. So when you see periodic table, right? So let me just write here this periodic table. When you see periodic table like this, okay. So this is block S. So basically periodic table divided into four sections. All right, so there will be four blocks. So you have block S here, and then we have block P, we have block D, and the other one underneath of periodic table, we have block F. Okay, so block S, P, D, and F is useful for you to remember that, for example, in block S, we have group 1 and group 2. All right, group and group 2. So for example, let me begin with lithium. Lithium is 3, so you will have 1s2, 2s1. Okay, and then one element from block P, which is for example fluorine. All right, so fluorine is 9. So the atomic, because fluorine has 9 electrons, therefore you will have 1s2, 2s2, 2p5. All right, so as you know already that 1 is actually the um, number of outermost shell electrons. So you have 1 electron in the outer shell of lithium. So then you will have lithium. Okay, so then you'll have lithium. Okay, so lithium atom will be stable if lithium loses its electron. Okay, so how many electron being removed from lithium is depend on the uh, valence electron that you have. In this case, lithium losing 1 electron, so lithium will be in the form of lithium plus and E minus. Okay, so if you're confused, you can see here, you can see basically you have a neutral atom on the lithium side, but then you have a +1 charge here. Okay, so this is actually +1. And then let me repeat one time. Uh, so this is actually +1 and this is actually -1. So if you have this, then this is actually neutral. All right. And then how about fluorine? Fluorine is actually 5 plus 2 is actually 7. So there will be like F plus E minus to give F minus. How do I get this? It is because of fluorine wants to be look like as a neon. Neon is actually 10. All right. So meaning you have 1s2, 2s2, 2p6. So it is easier for fluorine to get 1 electron to give 6 electron to get 6 electrons. So therefore, gaining electron, okay, so it means that it transforms atom becomes an ion. So you have atom here and this is actually ion, or because this one is negative, so negative, so put n, right? So just remember you have an ion, so you have same n, an ion. All right, now having said that, we can actually put them together. Okay, so you'll have Li plus, and then you have F minus, then you'll have LiF. Okay, so you just move the number diagonally. Okay, so you have Li1 plus, Fi1 negative, then you'll have LiF. Okay, so this is actually ionic bonding. Ionic bonding is basically sharing, transfer electron from positive ion which is cation, to negative ion which is anion. Okay, so cation is actually coming from group 1, group 2, and group D. And then anion is coming from group 5, group 6, and group 7. So if you have atom or element in group 1, if you have atom in group 1, so they will have +1 charge. Cation in group 2 is +2 charge. Cation or atom in group 3 in the form of cation, then they will have +3 charge. While this group 5 -3, group 6 -2, and group 7 is -1. So if you remember this, method, then it's easier for you to predict what is the ionic component you might have. Okay, let's practice one more time. So for example, we have Mg, because Mg is located in group 2, so it will have +2 charge. And then if you have, for example, chlorine group 7, then it will have -1 charge. So you just move the number diagonally. So you move here and you move there, then you will have MgCl2. Okay, name for this one is actually magnesium chloride. Okay, let me move to covalent compound. So covalent is actually it is a sharing electron. So let me just write sharing electrons. Right. So for this one is transferring electron. Okay, so sharing electron is actually coming from for two non-metal. Okay, so non-metals atoms. All right, so for example, C. All right, and then you have hydrogen. All right, so C is in group 4, so there will be 4 valence electron of carbon, and then you have 1 electron of hydrogen. Why 1 electron of hydrogen? Because basically hydrogen is located in group 1. All right, so you'll have dot and cross diagram of methane. Okay, so you'll have this one. Okay, so if we transform this one into other form, so you will have C, H, 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 H. Okay, so basically covalent compound is sharing electron. So the only thing that you need to see is actually where is the atom located. Yeah. So for example, you have fluorine. Fluorine is located in group 7. All right, and then oxygen located in group 6. So let's draw. O is actually 6. 1, 2, 3, 4, 5, 6. All right. So if we draw like this, then basically we might encounter difficulty to place the positions of hydrogen. So I have suggestions for you that you might remember. Okay. So when you have drawn or when you want to predict the shape of the molecule of OF2, then you'll have O. Okay, so this is how you distribute the electron: 1, 2, 3, 4, 5, and 6. And then since F is located in group 7, so there will be, like, let me use the other color. So when you'll have 1, 2, 3, 4, 5, 6, 7 of F. Okay, and then you have another F here on the left hand side. Okay, and then you'll have a 1, 2, 3, 4, 5, 6, 7. Okay, so when you got this, then you can simply find out that you have OF2. Remember, the reason why we do sharing electron, because we wish to attain a noble gas electronic configuration, meaning the outer shell electron of each atom should be 8, except hydrogen. I will making another video for covalent compound in the future. Okay, so last one is actually metallic bonding. It's actually just it is attractions between. All right, let me undo this one. So it is actually attraction between the positive ion with similar class of electron. Okay, so it's actually you have a positive ion. Okay, so in one layer, and another layer of positive ion, another layer of positive, and then you have a negative. Okay, you have an mobile electron. Okay, like that, you have a mobile electron. And if we see here, all right, if you can see here, basically in this diagram, we have a layer. So this is one layer, this is the second layer, and the third layer. Okay, so this is the first layer, second layer, and third layer. All right, now, having said that, if we exert, all right, let me undo, and then let me use red. So if we exert like specific force to one layer, and then if the force that you give to the first layer is greater than the inter bonding between first layer, right, first layer and the second layer. Okay, so it is actually possible. It is actually possible for the first layer to be moved. So there will be like this layer will be moved, for example, moved to the left hand side. All right, it will be moved to the left hand side, and this one will be uh, move. Okay, so for example, this one will be moved to the left hand side. Okay, and the distance between the first layer, right, distance between the first layer and the second layer is now different, right? Okay, so that's why metal, making it, okay, with these properties, metal becomes malleable. Malleable means that it is actually possible for you to shape different shape of metal. Okay, so you have different shape, like letter A, letter B, letter C. It's up to you, as long as you're able to give um, enough energy or sufficient energy to move the layer of the metal. Okay, so in your exam, you have to remember that I think this one, I just fix this one so you will have better clarity. So in your exam, they usually ask you to form a specific diagram for metal. So you have to at least you draw positive, positive, positive. All right, sorry, sorry. This one is still need some improvement. Okay, so you just draw positive, 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 positive. Okay, let me just draw 3 layers, and then the other one is actually negative. Negative, 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 negative. All right. So, and then let me use blue. All right. Okay, so you have to label. Basically, you have to label. Okay, so this one you have to mention is actually positive ion. Positive ion. And then here, sorry, undo. So this one you have to mention is actually mobile electrons. All right, mobile electrons, or you may say that's actually in some reference I read is actually they mention that this actually delocalized electron. Okay, so this is all from me. So if you have questions, you can ask me on the comment below. Thank you.